Hi, good morning. Happy Wednesday. So today I'm going to go over the second lesson, and this one is something new, but on my last video it did get cut off, so don't forget that the packet's due Friday at the beginning of class only. It got cut off when I was trying to show you guys the reflection over the x-axis, but that was just count one below, count two under, and then x was 7 to the line of reflection, so 7 under. That's what got cut off. But yeah, so let's talk about today's lesson, which is symmetry. Symmetry is pretty easy. Symmetry is like when something kind of looks the same on two sides. In nature, things aren't perfectly symmetrical, like our faces. If you cut our faces, like if you draw a line vertically down your face, you know, you'll have two eyes on both sides, your nose on both sides, and your lips. So we're not perfectly symmetrical, but there is symmetry there. And then in art, so symmetry is kind of in a lot of places, especially like nature too, leaves, things like that. So today we're just going to talk about symmetry really quick. If something has line symmetry, then it means that you can draw a line and it would fold onto itself. So here, if we look at this triangle, the line would be vertically right down. So that's the line of symmetry. And they can have more than one. Point symmetry is if you rotate it 180 degrees at the center. So if I draw like a little dot at the center of the N, if I rotate it 180 degrees, that means if I flip the paper upside down, does the N look the same? And it does. So this one has point symmetry. The triangle doesn't. You see how the triangle has the point at the top, but when you flip the page upside down, it's flat now. So this one doesn't have point symmetry. And then the last one is rotational symmetry. It just means that if you picked up this, looks like a sun, if you picked it up and turned it, rotated it, is it gonna land on itself? And it would, right? If I picked the sun up and I turned it, once it gets back to this point, it looks the same. Once it gets back to this point, it looks the same. So it does have a lot of rotational symmetry. So you're just gonna go through the examples and then decide what they have. Does this one have line symmetry? Yes. Okay, it has a lot of line symmetry. You can fold it. If you drew lines, you can fold it straight down the middle. Even though I didn't do a good job doing it at the middle. You can fold it on all the vertices, like the corners. So if I fold it this way, this half would meet. This one should have been a little bit more to the left here. And then even in the middle of the segments. So I'm gonna do a little bit to help me. So here and right about there. Okay, it does have a lot. That's line symmetry. You guys don't have to draw it, but yeah, it does have line symmetry. Does it have point symmetry that if you flip it upside down, yeah, it looks exactly the same when I flip it upside down. So it does have point symmetry. And does it have rotational symmetry? Yes. So if you started at a point and you rotated it, once it gets back to this segment, it would look the same. Or if you rotated it in the clockwise direction, once it gets back to the segment. For the triangle, line symmetry, yes, we can fold it right down the middle, and there's more. Point symmetry, no. So once I flip it upside down, 180 degrees, it's flat. It was pointy at the top, now it's flat, so it doesn't have point symmetry. Rotational symmetry, yes. Okay, if you picked up the triangle and you rotated it, once you get back to this vertex, it would have rotational symmetry, right? It would look the same, or this way. If you guys need help, you can look at your partner's paper. One of you could put it upside down, the other person can have it normal, and then if the shapes look the same at 180 degree rotation, then they have point symmetry. Okay, does this one have line symmetry? I don't believe so. You know, it doesn't matter if you fold it even this way, it won't work because this side will lean more to the right than the bottom. So it doesn't have line. Does it have point symmetry? So if you flip it upside down, so again, notice how it's pulling to the right and this side pulls to the left. Upside down, it does the same thing. It pulls to the right and the bottom point pulls to the left. So yes, it does have point symmetry. And rotational symmetry, it does, because if it has point symmetry, that means that I rotated it 180 degrees and it looked the same. So if they have point symmetry, they definitely have rotational symmetry, right? 180 degrees, it would go back to being how it was at the starting position. This triangle doesn't have any, okay? It doesn't have line symmetry. Point symmetry, 180 degrees, it's not gonna look the same at all, right? This flat side is gonna come to the top, and rotational symmetry, no. I mean, you can start to rotate your paper and see if it lands in a position where it'll look the same. Let me bring the water bottle down. That's what I'm using. Line symmetry, yeah, you can fold it right down the middle at least once, but there's more. Point symmetry, is it gonna look the same upside down? No. Okay, you notice how, the point's at the top and then there's two vertices on left and right, but when you bring it upside down, well, now they're at the top and the point's at the bottom, so it doesn't look exactly the same. Rotational symmetry, yes. Okay, if you picked up the star and rotated it, once you got back to that vertex, it would look the same. Line symmetry, no line symmetry. Fold it here. This side would go to the left, this one goes to the right, doesn't look the same. Okay, if you fold it horizontally, this goes to the bottom, this one, nope, doesn't look the same. And the diagonals won't work, so it doesn't have line, but it does have point. Okay, again, this one's pulled, this side is at the top right, this one's on the bottom left. So if you flip it upside down to 180, it looks the same. Top right, bottom left. And then it does have rotational symmetry. If they have point, they have rotational. It means 180 degrees worked. And that's kind of it. The lesson is really, really short. You should be able to go through and finish these. You should be able to finish them. You're also gonna finish the next page as well. And then a Delta Math assignment. If you want to do the Delta Math assignment first, it might help because it also animates the shapes for you. So I would go and do that and then you can come back and do this one. But yeah, if you guys need more help, I might put a couple more examples so you can check your answers, but double check with your neighbors, double check with your partner. For the bottom, you want to draw all the lines of symmetry that you can find, okay? And you're just drawing the lines. So for this one, the first one, all I can think of is a line vertically, right down the middle. Because horizontally won't work, diagonally won't work, it only has one. But some of them might have more, like this one has way more. So make sure you draw them all. For the back page, let's look at the back page really quick. Draw the line of symmetry. So again, this looks like a trapezoid. Where would the line of symmetry be? I can only think of right down the middle on the y-axis. So what's the equation on the line? You can say y-axis, or those of you that understand, or it's x equals 0, right? This is x equals 0 because all the points here have 0, -4, 0, -3, 0, -2, 0, -1, 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6. So they all start with 0, x equals 0. This one, make sure you draw all the lines of symmetry because it has more than one, and then you tell me the equations. Okay, tell me the equations of both of them. I think there's at least 2. Okay, well, hopefully that makes sense. For the bottom, order of rotation, it kind of just talks about how the order of rotation of a shape is the number of times you can rotate the shape so it looks the same. So honestly, it's going to be based on its sides. This triangle has 3 sides, so its order of rotation is 3. Okay, when you pick it up once, it's gonna look the same if I rotated it. Once I got back to here, twice, and then back to its starting position, 3.